it. Hey everyone, and welcome back to the channel. Today, we'll be tackling a topic that trips up almost every single person when they start learning to code: logic. It sounds like this big, scary, abstract concept, but I promise you, it's something you can absolutely master. It's just like learning a new language. At first, the grammar and sentence structure feel totally alien, but with practice, it starts to click. That's exactly what programming logic is. It's the grammar of coding. So, what do we even mean by logic? In simple terms, it's the set of rules and steps your computer follows to get from point A to point B. Think of it like a recipe. If you want to bake a cake, you can't just throw flour, eggs, and sugar in a pan and hope for the best. You need to follow a specific sequence. Preheat the oven, mix the dry ingredients, then the wet ingredients, combine them, pour into a pan, and bake for a specific time. Each step depends on the one before it. That sequence, that order of operations, is the logic. In coding, you're just writing the recipe for the computer to follow. Let's start with a super simple, real-world example. Imagine you're building a tiny piece of code that tells you if you need an umbrella. What's the logic? You'd start with a question. Is it raining outside? This is your condition. If the answer is yes, the program's action is take an umbrella. If the answer is no, the action is leave the umbrella at home. This is a fundamental concept in programming called an if-else statement. If this is true, do that. Otherwise, do something else. You use this kind of logic every single day without even thinking about it. If I'm hungry, I'll eat, else I'll wait. Coding is just about making it formal and telling a computer how to make those same decisions. Now, let us look at a classic beginner exercise. A program that takes a number and tells you if it's S, even or odd. How do we figure this out in our heads? We usually check if it's S divisible by 2. If you divide a number by 2 and there S no remainder, it's even. If there is a remainder, it's odd. That's our logic. We just translated our human thought process into steps a computer can understand. So the code's logic would be: Step 1, get a number from the user. Step 2, divide that number by 2 and check the remainder. We use a special operator for this, often a %sign, called the modulo operator. Step 3. If the remainder is 0, print even. Step 4. Else, if the remainder is not 0, print odd. So just built a complete piece of programming logic. It's all about breaking a problem down into the smallest possible steps. One of the biggest hurdles for beginners is getting stuck. You write some code, you run it, and ... error. It feels like hitting a brick wall. This is where your logic building skills really get tested. The first instinct is to get frustrated, maybe even want to quit. But this is the moment where real learning happens. Instead of panicking, take a breath and become a detective. Read the error message. It's not just random gibberish. It's a clue telling you where the problem is. Then, go back to your code and walk through it, line by line, just like the computer would. Pretend you asterisk the computer. If the user inputs the number 5, what happens at this line? And then this line? This process is called debugging, and it's 90% of what programming is all about. Don't be afraid of errors. See them as puzzles waiting to be solved. A powerful tool to help with this is something called SUPT. It's a fancy term for something simple, writing out your logic in plain English before you ever type a line of actual code. For our even odd example, the pseudocode is literally what we just said. Ask for a number. Check if it's divisible by 2. If there's no remainder, say it's even. Otherwise, say it's odd. By writing this first, you separate the problem-solving part, the logic, from the syntax part, which is remembering all the specific keywords and punctuation of the programming language. This makes it so much less overwhelming. You solve the puzzle first, then you translate your solution into code. You can even draw flowcharts with boxes and arrows to visualize the path your program will take. Building logic is a skill that grows with every single problem you solve. It starts with simple if-else statements. Then you'll learn about loops, which let you repeat an action over and over. Then functions, which let you package up your logic to reuse it. It never really stops. Even professional developers spend their days thinking about the best, most efficient logic to solve complex problems. So don't feel discouraged if it feels hard at first. It's supposed to. Every single developer you admire started exactly where you are, staring at a screen, completely confused. The difference is they kept going. They solved one small problem, then another and another. Each little victory builds your confidence and strengthens your logical thinking muscles. Keep practicing, stay curious, and celebrate those small wins. You've got this. Thanks for watching, everyone. If this helped clear things up, make sure to hit that like button and subscribe for more coding tips for beginners. Drop a comment below with the logic problem that's currently tripping you up, and let's see if we can solve it together. See you in the next one.